Hello, everyone. Here's a quick episode on how to use BERT, an updated version for 2024. Okay, so let me share my Google Colab. So we have done this, the Hugging Face and many times with NLP, so this is just an update. And I posted the code on GitHub, so you can go onto my GitHub to check it, but here's some explanations of what the code does. Essentially, we load the data, and I currently have it on my. So this is basically taking two 10K document of the product description, like the Hobart Phillips, um, and then we process them, the natural language processing, we process them, turn it into embeddings. Well, first to the tokens and then to the embeddings. Um, and then this embedding vector, we compute the cosine, right? So here is the Tesla 10K. And we can read them in. So we design, develop, manufacture, sell, and lease high-performance electric vehicles, so and so. So there's a whole description in the SEC 10K filings about what Tesla produces. And then there's Tricidia. It's a drug company. And again, it's a text file that I pulled from SEC 10K filings, and I'm reading that in to get this. So this is like it has periods, there are capital and small capital letters and all that. So what we do is that from the transformer, we import the BERT tokenizer, the BERT model. So that's what we'll do. And so here's the BERT base uncased, the tokenizer model. So it creates token, meaning it standardized the words and drop useless words. And then the model is BERT model, which is pre-trained by Google. So text one, the Tesla is called document one. We save it in a variable document one and text two in the document two. The first thing the tokenizer does is that it creates tokens. Um, so it's a PyTorch token in this case, with padding and truncation. So we make them all the um, here. So and then so the token one is the tokens for the Tesla, that product description, and token two is for Tricidia description. And then what we do is that so these are the list of the words, okay, and then what we'll do is that we get embeddings for that, and so the embeddings is that, so here with the model, the BERT model, we compute the embeddings. And then once we have the embeddings for Tesla and Tricidia, we can compute the cosine similarity by computing the cosine between these two and then run it. So these are just two short, a paragraph of document, and it gets you some kind of similarity number. If you're curious how the tokens look like, well, these are integers, the numbers, and what that is that these are each unique vocabulary, and there are many in the library. It's a unique number for each word, and these indicate which words are there in Tesla's product description, except for 101 and at the very end, 102, which are some end and beginning signal of the tokens. And similarly, you can look at Tricidia's token, which has slightly different composition of them. How does the embedding look like? So once you have and the tokens are, there's a long list, like English language probably has like 100,000 words. So that's a very long list. So rather than doing that, we use sort of an autoencoder-like idea. So encode it into a short, dense expression, a vector. So here you can see that the embeddings for Tesla is like some kind of continuous number like this, a vector. And the Tricidia, again, it's an embedding with the same length, but some different numbers. And basically, we are computing the cosine between these two very long word embedding vectors, right? So this is a short update on how to use the BERT with the 2024 version of the BERT tokenizer. Okay, thank you for watching this episode. Okay.